Space is rarely quiet, but for the galaxy known as J1007 plus 3540, the silence lasted for nearly 100 million years. And to us, that is eternity. To universe, it is just a nap. Deep in the heart of this distant galaxy cluster, roughly a billion light years away, a monster was sleeping. A supermassive black hole, millions of times more massive than our sun, sat dormant. It wasn't feeding, it wasn't glowing, it was a gravitational ghost. But then something changed. Suddenly, the central engine of this galaxy roared back to life. It didn't just wake up, it erupted with a violence that astronomers are now calling a cosmic volcano. We are witnessing a reborn black hole, and the blast it has unleashed is so large, it stretches across 1 million light years of space. Today, we are going to explore this incredible discovery, why this black hole is acting like a volcano, and what happens when a billion-year-old giant decides it's time to eat again. This discovery wasn't made with a standard telescope. You can't see this eruption with your eyes. To catch a cosmic volcano in action, you need to hear the radio waves it emits. An international team of astronomers led by Dr. Shobha Kumari used two of the world's most powerful radio telescope network. One is known as LOFAR, the Low Frequency Array in the Netherlands, and the upgraded giant matter wave radio telescope, which is also known as UGMRT in India. When they pointed these instruments at J1007 plus 3540, they didn't just see a single explosion. They saw a history book written in plasma. The images revealed a layering effect. At the very center, there is a compact, incredibly bright inner jet, the sign of a black hole that has just reawakened. But surrounding that new jet is a massive fading cocoon of older plasma. This tells us that this black hole is is like an AGN. It turns on, blasts the universe, runs out of fuel, goes to sleep for 100 million years, and then it does it all over again. Why are scientists using the word volcano? It actually is a very accurate, physical analogy. On Earth, a volcano erupts because of the pressure. Hot magma and gases build up underground until they find a weak point on the crust and explodes outwards, pushing through the atmosphere, leaving behind layers of ash. In space, the magma is superheated plasma, gas that has been ripped apart into subatomic particles. A matter falls towards the black hole. It doesn't all goes inside. Some of it gets caught in the intense magnetic field and is funneled towards the pole, where it is spat out at nearly the speed of light. This black hole lives in a galaxy cluster, which is a very crowded neighborhood. The space between galaxies here isn't empty. It is filled with thick, hot gas called intra-cluster medium. When the black hole erupts, its jets act like volcanic vents. They had to fight the punch through the thick gas. This created a massive cavity bubble in space that are 10 times wider than our entire Milky Way galaxy. What makes J1007 3540 unique isn't just that it woke up. It's the struggle it is currently in. The environment in this cluster is hostile. The external pressure from the surrounding hot gas is much higher than what most galaxies experience. Because of this, the jets don't travel in straight line. The data from LOFAR shows the northern jet being compressed and shoved sideways. It's like a garden hose being held against a strong wind. The plasma is actually being bent and redirected by the sheer weight of the galaxy cluster's atmosphere. To the southwest, astronomers found something even more haunting, a long, faint tail of the magnetized plasma. This is the smoke from the volcano of 100 million years ago. It's a relic, a ghostly reminder of the last time this black hole was awake, being dragged through the cluster like a wispy trail of ancient history. You might think these eruptions are just space fireworks, but they serve as a vital role in the universe. They are the thermostat of the universe. In a massive galaxy cluster, the gas should naturally cool down. When the gas cools, it clumps together and forms stars. It left If left alone, these galaxies would produce trillions of stars, becoming unimaginably bright. But the cosmic volcano stops that. By blasting heat and energy back into the cluster, the black hole keeps the gas too hot to collapse. It effectively shuts down the star formation. This black hole is essentially the landlord of the galaxy, deciding when stars are allowed to be born and when light stays off. This process called AGN feedback and is the reason why the largest galaxy in our universe are often red and dead, full of old stars but unable to make new ones because their central black hole keeps erupting. The billion-year blast of J1007 plus 3540 is the reminder that the universe has a heartbeat. It's not just steady one, but a rhythmic cycle of activity and silence. By studying this reborn monster, we aren't just looking at the explosions. We are looking at the evolution of the cosmos in real time. We are learning how black holes regulate the growth of entire clusters and how they transform their environment over millions of years. Next time, when you look up at a quiet patch of the night sky, remember there might be a monster there just waiting for its next 100 million year alarm clock to go off. Thanks for joining live. Thanks for watching. If you have any comments, leave them in the comment section below, and I will catch you again in the next one.